my channel Kuluru Vineeth. So today I'll be starting arrays playlist from easiest level to the hardest level. So today I'll be taking up a question called finding largest element in array. Okay, so let me pull up that question and see how does that question looks like. Okay, and before going to that question, I'd like to mention is that I'll be maintaining a public repo called Kotlin data structures and algorithms, and whatever coding questions I'll be coding here will put out into that repo, so we all can refer at later point of time. Okay, so here is the question. So as we can see, the example, assuming one example is our input array is 1 comma 2 comma 3 comma 4 comma 5. So the output that we should be able to extract from that is 5. That is a maximum element from that input array. So coming down to the intuitional approach, so the simple approach is traverse the array and keep track of the maximum element we have seen so far till the end of the array and return that element. Okay, so let me directly go down and write down that approach. So this is approach 1, traverse the array and keep track of max element. Okay, so I'll name this function as approach 1 and input is integer array, right? And since we are finding the maximum element, return type would be integer. And let's create one temporary variable called max and store initially the first element of the input array as a maximum element. Now iterating the given array, and the core condition check would be here is if the element we are currently at is greater than the max element we are storing, then we will store that value into max variable, right? So let me write down that approach. If max element is less than nums of I, we will store that variable into max variable, and at the end we just return that max value. So this is the simple answer that we could come up for this question. So after having written down this approach, coming down to the time analysis and space analysis, as we can see, we are traversing the array once and we are using one temporary variable for storing the required answer. So we can write down time complexity as order of n, as since we are traversing the array once, and space complexity as order of 1, since we are using one temporary variable. Okay, so is there any other approach again to solve this question? Okay, I can directly say that there is already out of the box max function available on integers array as an extension function, which is a power of Kotlin, which you will eventually see more of this kind. So okay, let me write down that approach directly. So using max function of int array. Okay, so let me name that as approach 2, and input remains the same, output return type remains the same. This is just one line code. So nums.max. Okay, so since behind the scenes the approach and the code they have followed is same as we have coded in the approach 1, the time and space complexity remains the same. So let me take this and mention that here as well, so that we can keep track of. Okay, fine. Okay, leaving aside these two iterative approaches, is there again a recursive way that we could come up with? Yeah, we could also write the recursive code for this. Okay, breaking down to simple steps, assuming our input array size is 1. So if the input array size is 1, we just return the initial element as our required answer. If not, what we do at each step is we break down the array into sub-arrays. I mean, at each step we reduce the size of array by 1 and go in search of the max element in those sub-arrays, and at the end return the max of all sub-arrays and current element. Okay, so I think it will be better clear if I write down that approach. So let me name this as approach 3 here using recursion function. Okay, and name this as approach 3. Here input remains the same again, but additional parameter, that is size of the array. This would act as the breaking condition for this recursion function. Okay, and return type would be same, integer. Here base condition is if size of the input array is 1, we just return first element of that array, or else we recursively track all subarrays. Okay, so here let's store that result into some variable called like rest of array max, and call that same function nums, except that the size of the array reduces by 1 at each step. Okay, and finally we return the max of that rest of array max in current element. Okay, so okay, fine, this was the approach 3. But now coming down to the time and space analysis, as we can see, again we are traversing the array 1, so the time complexity remains the same, that is time is order of n, and the space, since we are calling the functions multiple times, we need some place to store those functions, a kind of a stack. So at max we can call order of n functions, so the space complexity would boil down to the order of n, right? So these are the 3 approaches for this question. Okay, fine, we have written down all the 3 approaches. So let's now take some dummy example and see if the output for all the approaches remains same or not. Okay, so let's name this as the integers array 1, 2, 3, 4, 45 something 6. Okay, and also create an object of the above class I have created, finding largest element, and write 3 println statements to compare the result of each approaches. Max using approach 1 and use string interpolation to call respective functions. Okay, so let me take this and use the same for approach 2 and approach 3. Approach 2, approach 3, and change your name back to approach 2, and here to approach 3, except that we should add one more parameter, that is the size of the array. Okay, so now let's check what this output looks like. Yeah, as we can see, the output of approach 1, approach 2 and approach 3 is 45, which remains the same, and this concludes our all 3 approaches for this question. Yeah, that's pretty much for this video, and keep watching this channel, and keep looking for new exciting content coming in on this channel. Thank you.